Hi, good morning. Today we're going to work with the converse of the Pythagorean theorem. You can find this in lesson 7.5 of your textbook on page 320. Okay, so what you're going to use is the Pythagorean theorem to decide if a triangle is in fact a right triangle. So we all know that the Pythagorean theorem is a squared, which is one of the legs, plus b squared, which is the other leg, equals c squared, which is your hypotenuse. Hypotenuse is always the longest side. Now, if you're given a triangle and you're not sure if it's a right triangle or not, now how would we know if it's a right triangle? It would have a box in the corner, but this one doesn't. So we're going to use the Pythagorean theorem to decide if this is in fact a right triangle. So what you're going to do is basically just plug these numbers in for A, B, and C, and you're going to solve, and you're going to decide if a squared plus b squared does equal c squared, then it is a right triangle. And if it doesn't, then it's not a right triangle. It's either an acute triangle or an obtuse triangle. That you won't have to do until geometry in 10th grade. Today, you're just going to decide, is it a right triangle or is it not a right triangle? Now, the most important thing is you cannot round and you cannot estimate. So if a squared plus b squared does not exactly equal c squared, then you're going to say no. Okay, so don't round and don't estimate. So let's try this one here. We're going to try a couple of examples together. You can go to your book, page 320, for another review. I'm going to add extra videos, and then we are in lesson 7.5. We're going to work on this for 2 days. Okay, so is the triangle a right triangle? So I know this is going to be A. Remember, A and B are interchangeable. So if you call this B and this A, that's fine. As long as you call the two legs or the two shorter sides A and B, I'm going to call this C. Okay, now I'm just going to plug in A squared plus B squared equals C squared. Okay, so I'm going to get a calculator. I know this is 81. I know this is 1600. So I'm just going to do, okay, this one I don't know. I don't know 41 times 41. 1681. Now, let's see. I'm going to combine here. There we go. So as you can see, they are exactly the same. If you wanted to take the square root, you could, but you know they're going to equal the same thing. You're done. Pretty easy. This is a right triangle, so I'll put the little box inside and I'll say yes. Let's try another example. Here we go. Eeps. Sorry. Okay. Next example. I don't know if this is a right triangle or not because it does not have the little box inside. Okay, which one do I call A? Which do I call B? Which do I call C? I know this must be C because it's the longest side. Again, A and B, they're interchangeable. Doesn't really matter. I'll just call this A and I'll call this B. Okay, so now I'm going to write out the Pythagorean theorem. A squared, 18 squared, plus B, 12 squared. Oop, 12, sorry. 12 squared equals 24 squared. Pretty simple. Just going to plug it into the calculator. 18 squared. So squared is 144. I got 468 over here. And 24 squared, I don't think that's 468, but let me just check. Nope, it's 576. Therefore, it is not a right triangle. So you would say, no, this is not a right triangle. Okay, let's try another example where you're given A, B, and C. So on your textbook, page 320, now you're going to see there's some examples here you can go through as you do your IXL. Distance formula, we're not going to do this week, so you can skip that. Okay, so I'm going to do these two examples here. The first one is, they just give you A, B, and C. So they say 28, 21, and 20. Now, they don't tell you which is A, B, and C, so you're going to have to decide. They gave you 28, 21 inches, and 20 inches. Okay, So they're going to give you these three numbers. Now, which would you call A? Which would you call B? Which would you call C? C has to be the longest side. A and B do not matter. Now I'm going to plug into the formula. Remember the formula. And if you don't know this by now, you have to know this by now, right? Okay, so we have A squared, 21 squared, plus B squared, 20 squared, and we got C squared. Really easy. I'm just going to plug in the formula. 21 squared plus 20 squared, which is, of course, 400. 841. And we got 28 squared equals. So these are not equal, so we just write no, it is not a right triangle. Okay, let's try the next one. The next one in the textbook here, if you want to follow along, is 1.25 millimeters. The second side is 1 millimeter. And the third side is 0.75 millimeters. Okay, so we're going to try this example here. So which one is A, which is B, which is C? The longest side has to be C, right? So we're going to do, change colors. 1.25 is C. A and B don't matter as long as you use the two shorter sides as A and B. So we're going to do 1 squared plus 0.75 squared equals 1.25 squared. Calculator. 1 squared is obviously 1. 0.75 squared is 0.5625, so we got 1.5625, and I'm going to put in 1.25 squared. These are going to equal the same thing. Okay. They are equivalent. So therefore, this is, yes, it is a right triangle. Okay, if you need any more help with this, always email me. You can also watch the additional video that I put on Google Classroom, and you'll have 2 days to complete the assignments on this. Okay, so we're working on converse of Pythagorean theorem. You're just going to plug the three numbers into the theorem. Do not estimate, do not round, and they must equal the exact same amount. Okay, any questions? I'll talk to you. Just email me. I'll also set up a Google Meet this week if you have any questions. Thanks. Bye.